In this video, we're going to look at the next type of a non-homogeneous second order differential equation where fx is equal to e to the x or e to the power kx. So now what we're going to do in this type of question is to first form our auxiliary equation, so which is going to be m squared minus 5m plus 6 equals to 0. So we've done this in previous videos, so we get x minus 3, x minus 2 equals 0. Therefore the roots are m equals 3 or m equals 2. So our complementary function is going to be y equals to a times e to the power of 3x plus b times e to the power of 2x. So now we need to remember that our particular integral will now take the form of c times, now k in our case is 1, so it'll be c times e to the power of x. So we're going to assume that the particular integral takes the form of y equals c times, now if there was another power like 3 or 4 we would write it there, but it's only equals, so k is 1, so you write 1x there. So we do the usual procedure, we differentiate it, so dy by dx is simply going to be, well, the differentiation of e to the x is e to the x, so we get c times e to the x, straightforward enough, and dy by dx squared would be the following. So it's just going to be c times e to the x, because c is constant in this case. So what we're going to do now is substitute this into our differential equation. So it's going to be c times e to the x. Now don't forget it's minus 5 times dy by dx, so it's minus 5 times c times e to the x, and then we have plus 6 times the particular integral, so in our case it's going to be plus 6 c e to the x. Now all of that is equal to e to the x, just on the right hand side of our second order differential equation. So we can simplify this down to give me c e to the x minus 5 c e to the x will give me minus 4c e to the x plus 6c e to the x is equal to e to the x, and that simply gives me 2c e to the x is e to the x. So equating them, I get 2c is equal to, there's already a 1 here, so that's 1, and then c, I've just equated the coefficients of e to the x, so I get c is equal to a half, and so I can say therefore my particular integral is y equals to a half e to the x. So then I could write my general solution as follows. So I can say the general solution is y equals the complementary function plus the particular integral. So in our case, therefore the general solution is a times e to the x plus b times e to the 2x plus a half e to the x, and that will be our general solution. Here's a question for you to try. When you're done, you can pause the video and I'll go through my work solution. Okay, welcome back. So we're going to work out the auxiliary equation, which is m squared plus m minus 12 equals 0. So we get m plus 4, m minus 3 equals to 0. Hence our roots are m equals minus 4 or m equals 3. So our complementary function is y equals a times e to the minus 4x plus b times e to the 3x. So don't forget our function is now in the form of e to the kx. In our case, k is 2. So we're going to say that we're going to assume that our particular integral takes the form of y equals c times e to the 2x. So dy by dx, don't forget the differentiation of e to the mx from a regular interval is dy by dx is m times e to the mx. So in our case m is 2, so we get dy by dx is 2c e to the 2x, and likewise dy by dx squared will be 4c e to the 2x. So what we have from here is we can substitute these values into our differential equation. So it's going to be 4c e to the 2x plus dy by dx, which is 2c e to the 2x, minus 12 times the particular integral, which is 12c e to the 2x, is equal to 12 times e to the 2x. Now that's going to give me the following here. So I get 4 plus 2, which is 6. So I get 6c e to the 2x minus 12c e to the 2x equals 12 e to the 2x. So we can say that minus 6c e to the 2x is 12 e to the 2x, which implies minus 6 is equal to 12, and we can say c is equal to minus 2. So our particular integral has the form y equals c k to the x, or in our case y equals to minus 2 e to the 2x, and therefore our general solution takes the form y equals cf plus pi, y equals to a to the minus 4x plus b e to the 3x minus 2 e to the 2x is our general solution.